Let us do question number 4, part A. This question involves getting the inverse of a 3 by 3 matrix. We are required to get the inverse of the matrix A times B. The inverse of the product of matrix AB. To solve this problem, we need to first we get the product. Number one, we need to get the product of these two matrices. Matrix A we multiply by matrix B. After getting that product, then we get the cofactors of the product AB. We get the cofactors of the elements of product matrix AB. Number 3, we need, after that, we need to get the adjoint of the matrix product AB. After the adjoint, number 4, we are required to get the determinant of the product matrix AB. So we need the determinant of the product AB. Finally, to get the inverse of the product matrix AB, we need to get the adjoint of the matrix AB. We divide by the determinant of the matrix product AB. So here we divide by the determinant of AB. Those are the 5 things we need to do to solve this problem. I want us to start with the first issue, the issue of multiplying those two matrices A and B. So matrix A is equal to 1, -1, 0, then 1, 0, -2, then 0, 1, 1. That is matrix A. I want us to multiply matrix A with matrix B. So I want us now, we multiply that matrix with matrix B. This is matrix A, and now here we have matrix B, and the matrix B is 2, 2, 1, 1, 2, 2, 1, 3, 1. We want to multiply those two matrices so that we can get the product AB. To multiply these two matrices, we need to realize that we will get the column, the row of matrix A, then we multiply by the first column of matrix B. Again, we multiply the second row of matrix A, we multiply by the second column of matrix B. We repeat the same with the other matrix. That is, we get the third row of matrix A, we multiply by the third column of matrix B. And when we do that, we will be in a position to get all the elements that we are supposed to get. So let us start multiplying a row of matrix A times the first column of matrix B, and here we have that the first element is 1 times 2. We add -1 times 1. We add 0 times 1, That one we make the first element of the product matrix. We go to the second element in the first row of the matrix product. So we get the same row, we multiply by the column, the second column of the matrix B. So we get 1 times 2, we add negative 1 times 2, negative 1 times 2, then 0 times 3, we add 0 times 3, like that. Now we have the second element of the matrix, product matrix. Then we go to the other one. The other one is 1 times 1 plus negative 1 times 2 plus 0 times 1. So we now have the final element of the first row of the product matrix. Now we go to the second row. To get the second row of the product matrix, we are going to use the second row of A. We multiply by, again, all the columns in matrix B. And what we have now 1 times 2. We add 0 times 1, 0 times 1. We add negative 2 times 1, negative 2 times 1. And that is the first element in the second row of the product matrix. We go to the second element. We are going to get it by multiplying 2 with the second column of B. So we get 1 times 2 plus 0 times 2 plus negative 2 times 3, and now we have the second element of row number 2 in the product matrix. Then we go to the other element, that is 1 times 1. We add 0 times 2, 0 times 2, then we add negative 2 times 1, negative 2 times 1, and finally we have all the elements in the row number 2 of the product matrix. Then we want to get elements in the third row of the product matrix. Therefore, we are going to use row number 3 in matrix A. We multiply by all the columns of matrix B, and we start 0 times 2. We add 1 times 1, 1 times 1. We add again 1 times 1, and now we have finished with the first element in the last row of the product matrix. Then we go to the second element. We multiply by the second column of B. So 0 times 2 plus 1 times 2, 1 times 2 plus 1 times 3, 1 times 3. We get the second now, the second element of the product matrix. There, that is the second element. The third element is 0 times 1. We add 1 times 2, 1 times 2. We add 1 times 1, 1 times 1, like that. And finally we have the last element of the product matrix, AB. So that matrix now is AB. Let us now compute all those numbers. We get now the matrix. So AB is equal to, therefore, 1, 0, negative 1, 0, negative 4, negative 1. We are now here 0 plus 1 plus 1. Therefore, here we have 2. This is 0 plus 2 plus 3. We get 5. And here you have 0 plus 2 plus 1. We get 3. Now we have the product AB. We say that the second activity is to get the cofactors of this matrix AB. How do we get cofactors of a matrix? To get the cofactors here, like for example, I want us to start getting the cofactor of element 1 in the first row, first column. How do you do it? You remove all the elements touching the column with 1 and the row that is having 1. The matrix left out is a matrix of 2 by 2. That is, you remove all the elements which are in the same row and the same column with that element 1 there. So we are left with the matrix of a 2 by 2. And when you get the determinant of that matrix of 2 by 2 and you place the sign, then you get the cofactor. So cofactor of element 1 in row 1, column 1, it will be equal to here the determinant of the matrix 4, negative 1, 5, 3, that determinant, and then you place the sign. Now let us look at the placement of the signs. This is how you place the signs so that you can get cofactors after getting the determinant. We start with the positive in the first row, then negative, positive, negative, positive, negative, positive, negative, positive. So the element that is found in this position, you give it that sign. Like for example, in our case, the element in the first column, first row, that is the element 1, we are required to give it a positive sign after getting the determinant. Then it becomes now the cofactor. For example, the determinant here is negative 12 minus minus 5, because it is the product in the reading diagonal minus the product in the other diagonal. So it is negative 12 minus 5, and it becomes negative 7. Now when we come now to place the sign so that we can get the cofactor, we are going to give negative 7. We are going to place a positive or multiply with a positive sign here, and it will not change. That is the cofactor now. Cofactor of element 1 therefore is equal to, we put positive sign, we multiply it with the negative 7 there, and the cofactor now becomes negative 7. So the cofactor of element 1 in our matrix, product matrix AB, in the first column, in the first row, is negative 7 when we do placement of the sign, and we place the sign of depending on where the element is. If it is at the first position, the first row, the first column, you put positive. Then the second column, first row, you put negative, and so on. So that element 7, its cofactor is that. So Let us now go to the other elements. That is, we want the element in the first column, first row. We have seen that the cofactor here is -7. Let us now get the cofactors of the other elements. The element we want to get its cofactor is the element in the second row, first column. So, and that element is simply a 0. It is element 0 here. It is the element 0. Its cofactor is the matrix, is the determinant of this matrix. You remove the column and the rows that is touching 0, therefore we will end up with 0, -1, 5, 3. You get the determinant of that matrix, and then because the sign is negative, you put a negative there, and finally what we get, a negative or -5, you get +5. Then let us go to getting the other element, that is element in the third column, in the third row, column number 1, and that element is element number 2. And let us now get the cofactor there. If you remove the element in the same row and column with the 2, you are left with the matrix 0, -1, 4, -4, and the -1. We get the determinant of that matrix. Then we place the sign. The sign there corresponds to positive. So here we are putting a positive. -4, when you place positive there, you get again -4. Let us go to the other elements. The next element I want us to go to is first row, the second column. That's the element we want to go to, and that element actually is again a 0. To get the cofactor of that element, we remove the elements in the same row and the same column with the 0, and therefore we are left with 0, -1, 0, -1, and 2, 3, 2, 3. We get the determinant of that matrix. Then we are going to put a negative sign here because it is corresponding to negative. And what we have is simply 2. Then we place, because it is 0 times 3 is 0, 0 minus 2 is -2. Then we have 0 minus 2 is 2. Then we place a negative, and the cofactor here is -2. The next element is element in the second row and the second column. That element is -4. I want us now to get the cofactor of that element, and when we remove the elements in the same row and the column with -4, we get 1, -1, we get 2 and 3, 2 and 3. We get the determinant of that matrix, and when we place the sign to the determinant, it is positive. Then this one becomes a 5. This one becomes, because it's 3 minus -2, which is a 5. If you place positive to 5, you get again +5. we go to the next element. The next element should be element in the third row, and it is in column number 2. That element is the element 5. It is 5, and we remove the elements which are in the same row and the column with 5, and when we do that, we are left with 1, negative 1, 0, negative 1, 0, negative 1. We get the determinant of that matrix. And the sign here is, we place the sign is negative, and what we get there is this is 0, minus 1. This is 1 times negative 1. That one is negative 1. Negative 1 minus 0 is negative 1. Then we place the sign. So negative 1. We place the sign there is negative. However, the cofactor is simply 1. So we have finished the second column of our product matrix to get the cofactors. Let us now go to the third column. Now the element that we want to get its cofactor, the element in the first row, that is A1 in the third column, and that element is element negative 1, and we want to get its cofactor. The cofactor of this element, we are going to remove the other elements touching the same row and the column row, and the same column with the element negative 1, which now becomes 0, negative 4, 2, 5. We get the determinant of that matrix, and the sign here is positive to get the cofactor, and the cofactor here becomes 0 times 5 is 0, 0 minus 8, you get 8, so this is 8. Then you place positive to get a cofactor, and we get a cofactor is 8 there. Then we get to the next one, that is the element in the second row and the third column. That element is the element negative 1 again. And how do we get its cofactor? We remove the elements touching the same column and row with the negative 1, and what we get is 1, 0, 2, 5, 2, 5. We get the determinant of that matrix, and remember the sign now is negative, so 1 times 5 is 5, 5 minus 0 is 5, so we get 5, and then we place a negative sign to make it a cofactor. Therefore the cofactor is negative 5. We are in the final element, and our final element here is the element in column row number 3 and column 3, and that element is 3. How do we get its cofactor? We remove the elements to get the minor of 3, which is 1, 0, 0, negative 4. We get the determinant here, and we place a positive sign to make it cofactor, and the determinant is negative 4, because it is 1 times negative 4. You get negative, then you place positive 4, so negative 4. You place a positive there, and the final result is negative 4. So those are the cofactors of all those elements. Now, we said that when we get cofactors, we need to get the matrix of cofactors, and we transpose it. Negative 7, negative 5, negative 4, then negative 2, 5, 1, 8, negative 5, negative 4. That is a matrix of cofactors. This is a matrix of cofactors. The matrix of cofactors of A, B. After we get that matrix, we need to transpose that matrix. When we transpose this matrix, we get what we call the adjoint. We will get the adjoint of matrix A, B. And this adjoint now is now the transposed matrix of cofactors. And to transpose a matrix A is to convert the rows to become columns and the columns to become rows. And the first row becomes the first column in the transposed matrix. The second column becomes the second row in the transposed matrix. For example, in our case, our first column is negative 7, negative 5, negative 4, and it is a column there, so it becomes the first row. So it is negative 7, negative 5, negative 4. So that is that. We go to the second row, the second column, also we write it as the second row, negative 2, 5, 1. The other one is 8, negative 5, negative 4. Now we have transposed that matrix, and after doing that, we now have the transposed matrix of the cofactors of matrix AB, and it is the one we call the adjoint of matrix AB. The next activity we said is to get the determinant. And we say that to get the determinant of this matrix, that is the determinant of AB now is what we want. And the determinant of the matrix AB, and remember the matrix AB is 1, 0, negative 1, 0, negative 4, negative 1, 2, 5, 3. To get the determinant of this matrix, we simply get the sum of the cofactors, the product of cofactors with the elements in any row or any column. For example, I will use the first row to get the determinant. How will I do it? I will get the product of all of the first element with its product and with its cofactor. I add the product of the second element to its cofactor. Then I add the product of the third element with its cofactor. That sum gives you the determinant. If you look at the first row, or rather the cofactor of the element 1 is 7, so it will be 1 multiplied by 7. You add the second one is 0. You multiply by the negative 2, because the cofactor is negative 2. The cofactor there is negative 1. So you add the third element is negative 1. You multiply by the cofactor 8. When you do that, the sum, this one becomes negative 7 plus negative 8, and the determinant AB becomes negative 15. So it becomes negative 15, and that is our determinant. We want now to get the inverse of AB. I said that to get the determinant, we want now to get the inverse of AB. Product AB, we want to get its inverse, and we say that the inverse will be the adjoint of AB, which we already now have. You divide by the determinant of the product AB. So this will become the adjoint of AB the adjoint of AB is negative 7, negative 5, negative 4, negative 2, 5, 1, 8, negative 5, negative 4. That is the adjoint. The adjoint of AB. We want to multiply that one with or rather we divide with the determinant. Determinant is 15. So the determinant is 15. Therefore it will be 1 over negative 15. And the matrix now, or the answer for the inverse now becomes, you can retain the answer as that, or when you open, you multiply there, you get 7 over 15. 1 over 15 times that, you get 1 over 3. The next one is negative 1 over 15 times 4. That is positive 4 over 15. Negative 1 over 15 times 2, you get positive 2 over 15. The next one is 1 over 15 times 5. That is this is negative 1 over 3. The other one is negative 1 over 15 times 1. It becomes negative 1 over 15. Then the other one is negative 1 over 15 times 8. That is 8 over 15. That is negative. The other one is 1 over 3. That is negative 1 over 15 times 5 is 1 over 3. The other one is 4 over 15, because it is negative 4 times negative 1 over 15. And simply that is the inverse of the matrix, the product matrix AB. That is the inverse of that matrix there.